Okay, so hello everyone, this is Akshay here, and since past 2 days I was not so well and I was not able to make the videos. But yes, I hope you were able to cope up with the previous 2 days question, and if you still want me to make videos on those as well, please comment down in the section and I will definitely make the video for you. Okay, so let us now resume with the today's question. So it is the question name is find all four sum numbers, right? So we have been given an array A of integers and another number k. Find all the unique quadruple. Okay, unique quadruple we need to find it from the given array that sums up to k. Note that all the quadruples which you return should be internally sorted. Okay. So the answers which we need to return will be sorted होना चाहिए. That is for any quadruple q 1, 2, 3, it should be sorted in ascending order. Great. So for n equals to 5, k equals to 3, this is the given output, and the only one quadruple that is formation is 0, 1, 2. Similarly for second टेस्ट केस. तो ठीक है यार, इस क्वेश्चन में करने के मल्टीपल अप्रोचेस हैं. तो पहला अप्रोच तो क्या होगा कि दैट वी फॉर्म ऑल द quadruples using a nested for loop and power 4, right? And it also says that you need to return the unique quadruple. Like if there are multiple quadruple which is of the same, then you do not return it. Like in the example, let's say you have 1, 2, 2, 3, and 5, and let's say for some you have been given as 8. So you can clearly see that this 2, 3, 5 can make one 8, and this 2, this 3, and this 5 also can by 3. Let's say sum is 10, right? So even though there are two quadruples, but that are not unique, so we need to ensure that we return only the unique quadruple. So for that purpose, we are maintaining a hash set here of data type array list integer in Java. We will check the duplicacy, and that is the O of n for maintaining an array list, and that's an O of n for checking the hash set as well. So what is the time complexity we are using is O of n power 4, and if you see the constraint, n is pointing to 100, and if you do n power 4, it would be 10 power 8, correct? Which is less than equals to 10 power 8, and I think this solution will get submitted using the brute force technique as well. Let us see for the first method 1, then we can go for method 2 and method 3, right? Okay, so that's the code for method 1. So we have made an array list to store the answer and hash it, and then we are using a nested for loop, and then finding a sum for each and every quadruple formation. We are checking if sum equals to x. We are making a new temp array list, and we are checking if that particular array list, if it is not present in a given set, then only we will add an answer and add in the set as well. So this set will make ensure that you do not run into a duplicacy array list and you return into the answer, correct? Let us compile and run. So there is one more thing I need to explain you. If you see that the answer, my output is 0021, but the expected output is 0012. So there were one more thing that we need to ensure, that the quadruple itself in itself should be in the sorted format, right? So there are two ways now, that whenever we are forming a quadruple here in the temp array, we can call collection.sort on temp. That would be one, but we will be sorting each and every time we are forming a quadruple. So instead what we can do is that we can sort the array itself. When we sort the array itself, then ultimately the quadruple that will be forming, whenever if the sum is equals to s, it will make ensure that it is already in the sorted format. So let us compile and run once more. Let us see if expected and our output matches. Great, it matches. And we know the time complexity is n power 4. Let us hit the 7 button to see what happens. Yep. So as you can see, as I said, it would be n power 4, which would be touching the bound of 10 power 8. So it actually got submitted, right? Let us move ahead with the method 2 and method 4. Method 3. So method 2 is nothing but a certain optimized version of method 1. That is, we are actually doing a space optimization here. How we can doing it here is that we are using, without using the hash set, we will be able to tell that what are the what to say duplicate quadruples, right? So let's say for suppose this example, what will happen, that we know that this 2, 3, 5 would be an answer, and this 2 and this 3 and 5 would be an answer, right? So what we'll do is that whenever, let's say if I'm at this pointer, if I'm at this pointer, correct? So I will say that if my array of 5 equals to array of 5 minus 1, then I will not execute for this, right? Because let's say my pointer, when I was at this pointer, then definitely I found a quadruple using 2, 3, 5, and this 2 was nothing but this one, right? So when in the next iteration, if I see there's a similar element, because it's already in sorted format, so I can check if array of I, if equals to array of I minus 1, then in that case we will skip the iteration, and to skip the iteration we use the keyword continue, right? So these are the four, uh, maybe we can write 4 times for each and every for loop, and then we can omit this hash set step. So let me do that for you, and then we can resume back. Okay, so that is the optimization of method 1 in respect of space complexity. So we are actually commenting on the hash set part here, and then we are just adding 4 if statement in each and every for loop, because it's already in sorted format. So it is making ensure that if we are at the duplicate elements, and if there are duplicate elements present, it would be present in the side by side, because it's in sorted format. And yes, that would be it. Okay, and yeah, the compilation and submission has been done successfully for this approach as well. Now let us move ahead with the third approach. So in the third approach, definitely we will use the optimization that we have discussed in the method 2. So we'll be using here, that is, I'm saying without using the hash set. The first, okay. So there is one prerequisite here. You need to know that how we can form the two sum question, right? So it is nothing but, let's say, you have been given some values, let's say 1, 2, and then what, 2, 3, and 5, and 7. And you need to make a sum equals to 5, let's say. You need to make a sum equals to 5. So what you need to do is that you have a two-pointer approach here. So I and j would be here. And if you will see that if your array of I and array of j is nothing but greater than, so if I'm just writing array of I plus array of j is greater than your given sum, right, is 5, then definitely you need to reduce your sum, correct? So what you will do, you will move your j pointer from right hand side to left hand side by 1. So I will say j minus minus. Then again you will see it is 5 plus 1 6. It is again greater than your given sum. So you will move the j pointer again towards the left. Now you will see that it is 3 plus 1 4, right? Now your given sum is, that is, your array of I plus array of j is what? It is 4, which is lesser than your given sum, right? So definitely you need to increase your sum. How you'll increase your sum? You will move your I pointer to one step ahead in the right hand side direction. So you will just say I plus plus. And now you can clearly see that this is 2 plus 3, which is giving you the sum 5. And now you can just clearly return the indexes for this I and j for the given particular sum, right? So let's say, so if the question would have been given you for 3 sum, then you will run a for loop for I equals to 0 to I less than n, I plus plus. And then for the next two things, you can do 2 sum, right? So this question could be solved in n square. Similarly, for 4 sum, what you will do, that you will have a two nested two for loop running, right? And then here you will call the 2 sum function. And then this question can be done in, this is O of n, this is O of n, and this is O of n. So the 4 sum question can be done in O of n cube, and that is why I'm written O of n cube, correct? Okay, so let's just do this thing, and we need to add the optimization, the space optimization as well, which we have seen in the optimize method 1. So without using the hash set, we will add those two optimization as well. Now it is highly recommended for you guys to please pause this video here and try to code this approach yourself. It could be a lengthy code, like in terms of length it would be greater, but in terms of logic it is simple. I have showed you, right? So let's get ahead with coding the the third approach, and then we shall see what happens. Okay, so that is the last method of optimization we need to do here. So let me give you a very quick code walkthrough. So first of all, we are maintaining an array length. We have an array list so that you can return the answer. There is one base condition as well, that if the number of elements itself is less than 4, then definitely a quadruple cannot be formed, and we can return the empty array list. Now in to make that two sum method of the two pointer method to be applicable, we need to sort the array. So that's what we have done. Now there is a first for loop which will be going to n minus 3. Why n minus 3? Because uh, when you have, let's say, 5 this much elements, right? So the last iteration would be for the fourth last element, right? Because then you'll be able to make a quadruple. Similarly, for second for loop, we are going to less than equals to n minus 2, less than n minus 2. We already know this thing, why we include this if condition. That's the space optimization. Without using the hash set, we can just ensure that we do not include the duplicacy quadruple. Now what is this if condition doing here? So let's say let's say you have sorted the array, right? Let's say you have sorted this array, and you can clearly see that uh, the least number, that the first number would be 2 in this case, right? And let's say k equals to 1 was given to you. That means that your smallest element itself is greater than the sum to be formed. Then definitely in that case there would be no possible answer available, right? So this array of I greater than s is handling that particular case. And what is this thing is doing? Array of I greater than 0, it is making ensure, it is ensuring that, let's say if you have all negative elements or some negative elements, and also you have the sum to be made is also negative. So I'm just giving you an example here. So let's say array of I, some element is -2, the first element let's say is -2, and the sum you need to make is -7, right? So definitely -2 is greater than -7, but we cannot say for sure that the quadruple would not be formed, right? Let's say there was the elements -2 and some positive elements were there which would be making sum to -7. Or let's say some more negative elements were there like -2, and you have, let's say, the next element is -5, right? Like sort, it would be -5 first and then -2 on the right hand side, and definitely it will hit this case and you will say break. But we have seen that definitely an answer can be formed, right? So basically it is handling when you have negative array elements and negative sum as well, right? Okay, so there's a second for loop, and then we have to, now we are using actually two sum. So j plus 1 and l equals to the last, that is the starting and the ending index. And then we are just using the two sum, that while k less than equals to l, we are just finding the sum. If sum is equals to x, we are making a temp parallel and adding the answer. If sum is greater than s, then we are starting. If sum is greater than s, then definitely we need to move the last pointer one step ahead in the left hand side direction, right? So that's what I've done, l minus, and in the rest of the case, that is sum is less than s, then definitely your k plus plus, that is the starting pointer moving one step ahead in the right hand side, right? There is still one step is missing, that we have handled the duplicacy in this case and in this case as well, but we need to handle the duplicacy in this two pointer as well, right? So what is that case is, let's say you have 1 2 and then 3 3 3 4, right? So I and j would be here and you'll be doing two sum here, right? Correctly, this would be a, like if I say this would be k and this would be l. So if you have solved, let's say you need to sum, we need to make the sum 4 3 7, you need to make the sum, let's say 10, right? Then this two sum will definitely see 3 plus 4 7, and then this 3 would make 10, right? So I do not want to form or run the iterations again for the same element in this two sum as well, right? So I need to mention that space optimization technique in this two sum as well. So let us do that. And I don't know that how many threes are there, I don't know, right? So that's, for that thing we will use a while loop here. So let me just do the changes and we can see. So yeah, that's the changes, that we are storing the current pointer, that is the start and end, that is the k and l, in an old left and old right, and then we are keep on constantly checking if that my current pointer, that is if we are moving ahead, and if it is equals to my old k or old l, then we'll just move on incrementing the pointer k plus plus and l minus minus, right? That makes sense. You can do a dry run on this particular small snippet. Yep, that is it. Let us compile and run now. Right. So it has been successfully passed now. So let's just hit the submit button for this code approach as well. And again, what is the time and space complexity? That we are using the two for loop and one two sum thing which is taking O of n. So right, it would be O of n cube and O of n as the space complexity, because we are using an array list to return the answer, right? Great. Let's just switch back to C++ code. So that's the C++ code. That's the same that we have done in Java and Ryden, only there are some syntactical changes. Let us hit the submit button for this code as well.